So NASA holds a competition every year, and the idea is that they want to invite universities and different institutions, and they want them to compete in making a robotic system. And the idea is that this rover or robotic system can go to moon and accomplish a task. For instance, in our case, was digging the lunar soil, transporting it to a different location, dumping it. And the idea is that you will build a berm. We competed for the first time last year, where we had our senior students, they did this as part of a capstone project. The idea is, again, to be as creative as possible and accomplish this task as best as you can.
I heard about this, I think, from Dr. Liu. He recommended it to me as a project, and I thought it sounded interesting, so I joined. I started on this project last semester, and I've been working on it up until now. My focus right now is to be working on the seals to make sure none of the lunar soil simulant gets in any of the bearings or in the motors or anything like that. It's going to be kind of tough because the simulant is very fine and it's also really hard. So if it gets in any of the motors, it will break them. I think last year that was a bit of an issue with the motors breaking down partway through the competition, but hopefully I'll have that fixed. And I click on that one.
One of the major constraints here is energy usage. You're a moon. You don't have a lot of energy. You can't just plug into a socket. So you have to work under very optimized energy conditions. So you can't use a lot of battery power to run your rover. Another major issue is communications. How do you control the rover? So it's a very multidisciplinary approach that is required to solve these problems.
So first semester I did a lot of the mechanical and mechanical design work in general, so that's making CAD models, doing a lot of brainstorming, where now this semester I did a little swap and I'm now doing the communications and programming side. During the competition, we need to wirelessly communicate to the rover. So I'm in charge of setting up all of the little individual computers that will control the systems, and then getting the main overarching one that controls all those little ones to successfully connect over Wi-Fi to a router that we're controlling with a laptop.
These large-scale projects are very much dependent on collaboration, not just between the faculty, but between technical staff within the university. So downstairs we have very advanced machines which actually allow you to make very complicated parts and then bring them up here and assemble them. And we have a team of staff that have been very helpful for us, and the students actually are able to use the facilities downstairs. For example, you may need a part for the robot that you can't just order from somewhere. You designed it, you thought about this part, but it's just not off-the-shelf available part. So you basically say, well, I'm going to manufacture it here in Bradley. So we go downstairs, we have got very advanced machines that allow us to do that.
In the past with the Lunabotics team, we've created some plates that they've needed so they can affix those to the robot as they need to. The great thing about this building as a whole is it's the Business and Engineering Convergence Center. So we really like to focus on convergence here. That's what really makes it fun for me working with the Lunabotics group, because traditionally I'm more manufacturing or mechanical, those types of things, whereas a lot of the Lunabotics has a lot more knowledge from electrical engineering type of components. So for them to be able to come down and utilize this space in this building is an amazing thing to converge together to do all those.
So my role within the Lunabotics team this year is I am the mechanical team lead. So I'm responsible for producing all the parts in a CAD drawing. So while the rest of my team is working on developing the electrical system and the power system and the software of it, I'm working alongside them in creating the physical robot in which they are going to integrate their electronics into. We have to have the ability to create the infrastructure for it and the framing, and this is the space that we will be able to use to create those parts. Once I get done creating the part in a two-dimensional drawing, I will come down here and I'll see the shop director, and he will assist me in creating the part. And at the end of that, I will be able to take that part, polish it, and do any post-processing to it. And then from there, we can take it up to the lab and actually put it into the rover.
One aspect of a project like this is the students get to be exposed in real life environment. It's a lot of stress, but when it's time to actually go to the competition, it's euphoria. It's a mix of apprehension that your robot will just sink in the sand or not start, and then at the same time, it's excitement that, well, we have accomplished something great, we want to see it work. So it's a very rewarding experience.